Hi everyone, welcome to this episode of Kuiper Labs. In today's video we're going to talk about our series of constructing graphs, part 1, which graph do I use? We're going to start by looking at why do we use graphs in science and scientific investigations. We're going to look at which graph type might we choose based on our circumstances. We're going to look at two very similar but different types of graphs called line and scatter graphs. And then we're going to go through some tips and rules for how to construct graphs, whether by using a device or by hand. So firstly, why do we use graphs like these ones that you see here? What's the point of choosing them at all? Well, ultimately, graphs allow us to identify patterns, trends, and relationships in the data that is being represented. It's a form of communication that scientists or mathematicians or in the media that is used to communicate information in a certain way, or to be able to see things that just numbers in a table wouldn't be able to show. But it's important that part of why we use graphs and how we use them is the type that we choose. And the type or the graph that we would actually choose or go with depends on the type of data that we're trying to show. What sort of information are we trying to convey and how would be best to go about that? So, if we look at an example here, this is a graph representing, adding masses onto a spring and seeing how far it stretches or it extends in centimeters. We see we've got points that are plotted with x's and we've got a straight line showing this trend and pattern, because we have two variables that are measured. Whereas, say, if we've got looking at the different numbers of animals in a particular field, we might show it in a column graph like this, where we've got labels down the bottom and numbers up the side. Okay, so that in this situation, our independent variable is a categorical or a name kind of variable, whereas our dependent variable is discrete. That is, we have set numbers of animals that might be present in the field. You also don't have any half numbers. You don't have 2.5 foxes. You have integers or whole numbers. And so we might use a column graph. What about if we have this situation where we look at what happens when different metals are added to acid? We have two categories. We've got a metal, so we've got word categories here, and we've got a written observation. In this situation, that a graph is not appropriate. We would leave it as a table because both variables are categories. Neither of them is a number, whether continuous or discrete. So it's also about knowing when it's not appropriate to use a graph as well. So here we've got a little bit of a kind of a way for us to work that out. So look at, is your independent variable a number? If it is, use a line or scatter graph. We're going to go through the difference between those in a second. But these would be the types we'd choose. If your independent variable is discrete, we have set kind of numbers and gaps, that then a line graph is probably the best thing to choose. But especially also because the idea of a line graph is that it shows local trends, that is, trends around certain spots on our graph. Whereas if your independent variable is continuous, that is, it's a number on a sliding scale, that then a scatter graph that shows the overall trend is a better way to go. It's more useful to show that pattern in the data. And you'll see these two types in a moment. If the independent variable, though, is not a number, you'll either need to have it as a column graph or leave it as a table, depending on whether your dependent variable, the one you're measuring, is a number or not. Okay, if it's a number, then a column graph will work, but if it's not, then they're both categories and you leave it as a table. Now, I understand that there's a fair bit of kind of description I've just thrown at you, so I've put it together as a flowchart to be able to help you to work out. So first, let's start with, is my dependent variable a number? If it's not, then a graph is not going to be appropriate. Leave it as a table. If your dependent variable is a number, well then, okay, we need to make further choices. If the independent variable then is a number, then a line or scatter graph would be the best way to go. If it's a categorical, pick a column. Okay, if you want to show local trends, that is what's happening between one point and the next point, then use a line graph, which works like dot to dot. If you want to just show the overall trend, then a scatter graph is the way to go. Okay, so hopefully this helps you in trying to make a decision about what graph type is going to be the most suitable for the numbers or the data that I'm trying to show. Now, how do we tell, or what's the difference between a line and a scatter graph? I've spoken about it verbally. Let's see what this looks like. So this is an example of a line graph. Okay, so we have categories or kind of numbers going across the bottom. We could label these months by their number. We have set gaps between them. But the idea is that a line graph has lines joining from one point to the next point, all in a sequence. Now, the reason that we might choose this is that if we're trying to show local trends, that is, not just looking at a pattern from one end to the other, but what's happening from one month to the next month. What happens from that month to the one after that? So for example, this is our local trends. We're saying, okay, from March to April, that then this goes up massively. From August to September, August is being the highest, and then it drops back down. Drawing a line graph allows us to see those patterns more clearly. And so it works best if our independent variable is discrete, like the months of the year, or set numbers that have a specific gap between them that is consistent. Okay, because then it helps us to be able to see things more clearly. Whereas, say this is information about a scatter graph. Now, admittedly, this graph doesn't look like it's the best quality, perhaps. The numbers, the points are all over the place, but there is a relationship that's going on here. Real-world data often is a little bit messy like this, and so graph choice becomes even more important. So this is designed to show the overall trend in the data. Rather than doing dot to dot, we're looking at, as time went on from 1900 to 1920, what happened to this local index over time. Okay, we will draw a line of best fit in a scatter graph. Is the term we use, but it may or may not be a straight line. Something to keep in mind, it might be a curve rather than a linear or straight line relationship. It depends on what the data is showing, what pattern will fit it best. And that's some of the decisions that we need to make, but scatter graphs will show this line of best fit as an overall trend rather than a dot to dot sort of pattern. Okay, let's have a look at some of the rules that we would use in constructing a graph. Okay, so if we're trying to build one from scratch, what do we do? First of all, our graph we need to write a descriptive title. Okay, it sets the scene. This may be the last thing that we write in terms of, once we've kind of gotten everything there together, and then it kind of sums up what we're showing. But the title for the reader sets the scene. Okay, it's important that we label both axes and write units in brackets where relevant. Now, what we're representing on an axis, whether it's the down the bottom on the x-axis or up the side on the y-axis, may not involve units, but if there are units, you better write them so that it's clear to the reader what the measurement is. Place the independent variable, the one you're changing, or it is being changed, on the x-axis, so down the bottom. That means the dependent or measured variable goes on the y-axis, goes up the side. Okay, we always do it in this way for a consistency of pattern. That when we're doing our scale, which will be the basis of our next video, our median boxes need to go up by multiples of 1, 2, or 5, or then multiples with 10, like 20, 40, 60. Okay, so that we get a nice way that we can interpret and draw the data. Now, some of these things, there's more aspects we need to do when drawing by hand, as opposed to drawing on a device. You've got to use at least half the paper or the area so that it's not too cramped. We want to be able to see things clearly rather than having it squashed in a corner. We need to carefully and correctly plot all the points so that we can accurately see the trends. If it's sloppily done, we might misinterpret things, so we have to be careful. We use graph paper so that it's clear and simple to read, and it's also neat for the person constructing it to use. You have straight lines, you have grids, you have already kind of established sort of patterns of boxes to make it easier for you. And we also use pencils so that you can correct any mistakes. If you use pen and you have mistakes, you've got to go through a very long process or messy process to try and fix things up, or you need to start it again. If you use pencil, you can make those adjustments as required and still make it neat. Okay, so we looked at why do we use graphs. We're trying to use graphs to showcase the data we have to clearly see any trends and relationships that might be there. We know that we need to choose the graph type based on the data we have. Do we use a line or scatter graph? Do we use a column graph? Or do we not use a graph and just leave it as a table? Looking at the difference between line graphs and scatter graphs based on whether we're looking for local trends or overall trends. And also looking at some of the rules and tips for constructing graphs to give us the best quality, to make it easiest to read and clearest for the reader to understand. All right, thanks very much for watching. Don't forget to like and subscribe. Have a look at the next ones in this series for more tips about graphs, and bye for now.